Hello everyone, this is Sung-Hee Kim from Dong-eui University. Today I would like to share the results of a comparison study of touchscreen and mouse for real-world and abstract tasks with older adults. This is a short summary of a TACCESS publication. Older adults suffer from cognitive impairment, and the timely identification is considered a healthcare priority. Traditionally, cognitive testing is done in the clinic and requires trained personnel for administration and scoring that leads to a long waiting time. CTALK project was designed with an ultimate goal to be self-administered, web-based, computerized test, which older adults can take independently at home. Compared to paper-based administered tests, CTALK tasks require somewhat more cognitive effort. The motor skills required for pointing or dragging an object are part of the problem-solving process and could have impact on the results. Therefore, we ask the following research questions, which should be determined before deploying computerized cognitive testing systems. First, to determine if performance on computerized cognitive tasks are affected by two types of input devices, mouse and touch. Second, determine if performance differences due to input device can be explained by those observed on Fitts law tasks. Among several CTALK subtests, we selected 4 tests that use both pointing and dragging interaction, as well as relatively low and high precision tasks. We then mapped these to abstract Fitts tasks, controlling for index of difficulty throughout. Here are 4 types of tasks that are divided into pointing and dragging and low and high precision tasks. For real-world dragging tasks, we defined an intended target zone. The intended target zone size is larger in the low precision task. For example, you can see that in the sentence comprehension task on the left, the intended target zone shown in gray is larger compared to that in the pattern construction task on the right. Abstract Fitts tasks are compared to our CTALK real-world tasks. For our abstract tasks, we use classic multi-directional pointing and dragging tasks, which we modified to better mimic CTALK tasks. The 3 index of difficulties reflect the task precisions in CTALK subtests. The specific parameters are given on the slide for a Fitts law performance model. We recruited 16 participants, of all whom are right-handed. For dexterity, the pegboard results are above the normative data for their age group. There were 4 factors in our experimental design: task type, input device, interaction type, and task precision. It was a within-subject design. Here we share an overall summary. First, considering speed for pointing tasks, people are overall faster on touch screen than with mouse, regardless of precision or real-world first abstract task. For dragging tasks, as the precision level gets higher, touch is faster than the mouse. Moving to accuracy, input device affects only one of the 4 cognitive tasks, the high precision arithmetic task, which is high precision pointing, had higher accuracy with a mouse than touch. For the other 3 cognitive tasks, accuracy does not differ significantly based on the input device. These findings fully parallel the findings on Fitts law tasks. Result details can be found in the paper. One of the most important limitations of self-administered computerized cognitive testing is the lack of the qualitative performance data that an examiner might collect through observation while in the same room as the test taker. Therefore, we coded behavioral patterns with pattern construction tasks to gain qualitative performance data. We found different patterns between input devices. For example, participants seem to make more dragging moves with a touch screen than with a mouse. More findings are reported in the paper. We validated findings on pointing and dragging tasks with different input devices and extended them to real-world tasks. We suggest 3 implications for design. For example, provide support for decomposable dragging tasks. We further provide 2 for deployment. For example, in order to deploy a cognitive test on both PC and tablet, normative data would likely be needed. Overall, device-specific difference in performance by older adults on CTALK tasks suggests that a larger scale study will be needed to find valid performance calibrations across devices. Thank you for your attention.